The way software engineers work just fundamentally changed, and most people don't even realize it yet. OpenAI just published a breakthrough article on harness engineering, and it's basically the instruction manual for how AI and humans will collaborate on code from now on. Here's what makes this special. We've all heard about AI writing code, right? ChatGPT can generate code snippets. GitHub Copilot fills in the next line, but harness engineering is completely different. It's about understanding how to structure your entire system, your prompts, your workflows, so that Codex, OpenAI's code model, becomes a genuine partner in your development process, not just another autocomplete trick. The real insight is that writing code with AI isn't about replacing developers. It's about humans doing the creative, decision-making work, while AI handles the scaffolding, the repetitive patterns, the boilerplate, the infrastructure that every project needs but nobody actually enjoys building. Think of it like how architects design buildings but rely on construction crews to actually construct them. Except now the construction crew is getting smarter. Codex understands context better than ever. It knows what you're building, not just the syntax you're typing. When you combine that with proper harness engineering, the right prompts, the right system design, the right feedback loops, you get developers shipping features 3 to 5 times faster while maintaining higher code quality. And here's what surprises most people about this story. To understand why harness engineering matters, you need to first understand what a harness actually is in this context. Imagine you're trying to teach a really smart dog to do something useful. The dog has incredible potential, it's intelligent, it learns fast, it understands nuance, but without proper training structure, it'll just run around doing random things. A harness isn't about limiting the dog. It's about channeling that raw intelligence into something productive. That's exactly what harness engineering does with AI code models. For years, developers have been treating AI code generation like a magic trick. Prompt it the right way, and sometimes you get gold. Most of the time you get code that works, but isn't great. The problem wasn't the AI. The problem was the lack of structure around how the AI was being used. Harness engineering is the framework for that structure. It's about designing your entire development workflow, the prompts you write, the context you provide, the feedback loops you build, so that Codex actually understands what you're trying to accomplish and can generate code that fits your architecture, your style, your team's patterns. This isn't new in theory. Companies like Google, Meta, and various AI teams have been using these techniques internally for months. But OpenAI just published the comprehensive playbook that shows every engineer how to do this themselves. Here's the pattern that changes everything. The agent-first world means thinking about AI not as a tool you occasionally ask for code suggestions, but as an active participant in your development pipeline. Here's how it works. Instead of you writing code and asking Codex to fill in a few lines, you're designing a system where Codex actively generates major chunks of code, and you review, refine, and integrate it. The key word there is active. The AI isn't waiting for you to ask. It's part of the process. Think about it this way. A traditional developer workflow is write code, test it, debug it, refine it. That's mostly human work. An agent-first workflow is describe what you need, let the agent generate possibilities, evaluate and iterate on those possibilities, then integrate the best solution. The agent is doing the initial lifting, and humans are doing the thinking and validation. Codex in an agent-first system becomes genuinely powerful because it's not just auto-completing a line you started. It's generating entire functions, entire modules, based on context it's been given about your project's architecture, your naming conventions, your testing patterns, your performance requirements. OpenAI's article shows that the secret to this is what they call scaffolding. You create a template, a structure that the AI fills in intelligently. You set guardrails, you provide examples, you create feedback loops that teach the model how your team actually works. When you do this right, developers report that code generation accuracy goes from maybe 60% to over 90%. 90% means you're not reviewing garbage. You're reviewing work that's already pretty solid. But here's the twist that nobody expected. This isn't theoretical. Real engineering teams at major companies have been using harness engineering principles with Codex for months, and the results are pretty staggering. Companies like Stripe, Shopify, and others in the OpenAI ecosystem reported that when they properly harness Codex, when they structure their prompts, provide the right context, and integrate it into their actual development workflow, they see marked improvements. Code review cycles get faster because the generated code is actually good. Onboarding new engineers gets easier because junior developers can pair with the AI to understand codebases faster. And most importantly, experienced developers can focus on architecture and problem solving instead of writing the 10,000th, slightly different version of a database query. One concrete example, a team building a web service found that by providing Codex with examples of their error handling patterns, their API response structures, and their logging standards, the AI started generating code that didn't need major rewrites. Before harness engineering, they'd get something that technically worked but didn't match team style. After, it just fit. Another pattern teams discovered: when you give Codex access to your actual codebase structure, your existing tests, and your architecture documentation, it doesn't just generate code. It generates code that respects dependencies, doesn't break existing interfaces, and passes your test suites. That's a huge change from the AI wrote something vaguely related to what I asked. The really interesting part is that each company's harness looks different. One team's scaffolding might be completely different from another's because it's tailored to how that specific team works. But here's what all of them discovered in common. You might be wondering, isn't GitHub Copilot already doing this? Aren't there a dozen other AI coding tools? What makes harness engineering different? GitHub Copilot is incredible at one specific task: its next-line completion. You start typing a function, and it predicts what comes next. It's like autocomplete on steroids. That's genuinely useful for small, predictable code patterns. But harness engineering is a different category entirely. It's not about predicting the next line. It's about generating entire architectural decisions, entire modules based on your system's design. It's higher-level thinking. Other AI tools like Tabnine, Codium, and others do similar things to Copilot. They are good at line-level completion. Some newer tools try to do more, but most lack the architecture-aware context that makes Codex powerful when it's properly harnessed. Here's the key difference. Those tools work on the code you're actively writing right now. Harness engineering works on the entire system structure. You're giving the AI information about your project's patterns, constraints, style guide, testing approach, and it uses all of that to generate code that belongs in your codebase. It's the difference between a tool that's really good at finishing your sentences and a tool that understands your writing style well enough to draft entire paragraphs you just need to edit. One is incremental improvement. The other is a different way of working. The speed up isn't 3 times faster at typing. It's 3 to 5 times faster at shipping because you're spending less time on the parts anybody can write and more time on the parts only you can think of. And that speed advantage creates an advantage nobody expected. Here's what makes harness engineering scary for some companies and exciting for others. It creates a massive speed advantage, and speed in software development compounds. When you can ship features 3 to 5 times faster, you can iterate on user feedback 3 to 5 times faster. You can run more experiments. You can course correct quicker. In a market where being fast matters, which is basically every software market, this is huge. A startup using harness engineering effectively can do the work that traditionally took a team of 8 in about the time it took a team of 3. That doesn't mean those 3 people are equivalent to 8. The developers themselves still matter enormously. But it means the productivity multiple gets multiplied. 3 really good engineers with proper harness engineering can move like a traditional team of 10 or 12. That has implications for hiring, for speed to market, for which companies can scale and which ones stagnate. There's also a consolidation effect. Companies that figure this out early get ahead. Companies that don't start feeling the gap grow wider. You know how some teams just ship faster than others? That wasn't always just about talent or luck. Sometimes it was about process. Harness engineering is about process. But unlike old-school process improvements that slow you down with more steps, harness engineering actually makes you faster. For individual developers, it changes what skills matter. You're not being replaced, you're being multiplied. The engineers who understand how to work with AI as a partner, who can architect systems that AI can understand and generate for, those engineers become more valuable, not less. But here's what the OpenAI article reveals that most coverage is missing. The beautiful part about OpenAI publishing this framework is that you don't need to be a big company to use it. Any developer can start harnessing their own workflow right now. Step 1. Document your patterns. Write down how your team actually solves problems. That might sound boring, but it's the foundation. If your team always structures error handling one specific way or names functions with certain conventions or structures API responses a particular way, write it down. This becomes the vocabulary the AI learns from. Step 2. Create examples. Don't just tell Codex what you want. Show it. Include 3 or 4 complete examples of the kind of code you're trying to generate. When the AI sees real examples from your codebase, it understands your style viscerally, not abstractly. Step 3. Provide context. This is where many teams skip important work. Give Codex information about your architecture, your dependencies, what problems you're actually solving. The more context it has, the better it generates. Step 4. Test and iterate. Generate code, review it, keep what works, feedback what doesn't work, and refine your harness. The harness gets better with use. Step 5. Integrate into your workflow. Don't treat Codex generation as a separate process. Make it part of how you actually work. Maybe it's how you bootstrap new files, or how you generate boilerplate, or how you implement well-defined algorithms. You don't need fancy tools for this. OpenAI provides guides. Developers are publishing frameworks. You can start with basic prompts and your existing IDE. The real secret is treating your development workflow as something you can engineer for AI collaboration, not just as something you've always done. Here's what comes next. So here's what this all means. Harness engineering isn't the future, it's the present. OpenAI just made the playbook public, which means the next 6 months will be wild. Every serious engineering team will figure out their own version of this. The developers and companies that understand harness engineering early will ship faster, iterate smarter, and stay ahead of everyone else. The ones that don't will slowly realize they are falling behind without quite understanding why. This isn't about AI replacing developers. It's about developers who figure out how to architect systems that AI can genuinely partner with. That's where the leverage is. That's where the future actually is. If you're building something, start thinking about this. What does your development process look like if you assume AI is a full participant, not just a tool? What patterns would you document? How would you structure your codebase so Codex could help build it? These questions matter because the answers are going to determine how fast you can move compared to everyone else. The thing to watch. In the next 90 days, which companies start shipping significantly faster, which teams start talking openly about using harness engineering, those are the ones that understood this story before it became the obvious thing everyone talks about. That's what makes this moment so significant. The capability is here. The playbook is published. It's literally just down to execution now. And the teams that execute on this framework first are the ones that win.